Hey guys, it's Marina, and today we're going to be doing 1.8 and 1.9. So we'll be talking about rational functions, zeros, wholes, and whatnot. So yeah, let's get started. Okay, so we're going to be starting off with zeros, and basically all that means is that we're going to be looking for what x values will make this numerator of the function equal 0. So we can just factor this out, and we're going to be thinking what two numbers multiply to -8 and add to 2, and those two numbers are -2 and 4. So we can factor this out to x minus 2 times x plus 4. And that means that our zeros will equal x equals 2 and x equals -4. And this doesn't really affect the domain because it's not going to make the function undefined since it's just the numerator making it equal to 0. So it's just going to be -infinity to infinity. And we can also see that in this graph right here. There's no point where the function doesn't exist, but you can see that at x equals 2 and x equals -4, the y value is 0. Okay, so now we're going to be talking about wholes, and this is basically the same concept, except we're going to see what cancels out on both the top and the bottom, and you'll see what I mean by that once we start breaking it down. But we can see on the bottom here, there's an x minus 4. So we can factor out the top to see what we're working with. So we're going to think what two numbers multiply to -12 and add to -1. And those two numbers are -4 and 3. So we can factor this out to x minus 4 times x plus 3. And then we still have this x minus 4 on the bottom here. And here you can see that there's an x minus 4 on the top and the bottom, so that's what I mean. You can cancel those out, and that is what we call a whole. So there's going to be a whole at x equals 4, and there's nothing else we can cancel out, but we can see that we still have this x plus 3 in the numerator, and that is going to be our 0. So here's the one at -3. And then for your domain, you don't really care about the zeros because that's not going to make the function undefined at that point, but you do care about that whole because that's what's going to make it undefined. So you just want to make sure when you're describing your your domain, you don't want to include that 4. So you can do that by using your parentheses, doing -infinity to 4, and then 4 to infinity. And if you really want to graph it, you'll see that at x equals -3, the y will be 0. And at 4, wherever that y value is, it'll be around 6 or 7, but it'll be a hole right there. I believe your graph will look kind of like this. But yeah. Okay, now we're going to be talking about vertical asymptotes. We can go ahead and start with the skills that we already know to do. So we're going to start factoring out the top and bottom. So here we can factor out that 4 to just 4 times x plus 2. And then on the bottom, we're just thinking what two numbers multiply to -10 and add to 3. And those two numbers are -2 and 5. So it's going to be x minus 2 times x plus 5. And here we can see nothing from the top and bottom cancels out, so there's no wholes. But we know that the 0 will be at x equals -2 because of this part right here. And then vertical asymptotes, to find that, we're just going to see what makes the denominator equal 0. So here we can see that it would be at x equals 2 and x equals -5. And so for our domain, we're just going to make sure not to include the wholes, but we don't have any. And then whatever our vertical asymptotes are. So we can do that by doing -infinity to -5. Then -5 to 2, and 2 to infinity. And you can also see this on the graph. Here at -5, you can see there's a vertical asymptote. Although it's approaching that x value, it'll never actually reach it. And then also here at x equals 2, there's another one. Okay, and for this next one, we are going to be adding two new skills, which is finding the horizontal asymptote and the y-intercept. So before we start factoring anything out, we're going to look at the original function for the horizontal asymptote. We're going to look at the powers, the highest powers of both the top and the bottom. And here, they're both 2. And in this case, when they're equal, you look at the coefficients, which here are just 1 and 1. So there's a horizontal asymptote at y equals 1. But if we're a situation where the top power is higher, then there's not going to be a horizontal asymptote. And if the bottom has a higher power, then the horizontal asymptote would be at y equals 0. But here it's y equals 1, because those are the coefficients divided by each other. And now we can just do what we've been doing, which is factoring it out. So here on the top, it's a difference of squares. So it's going to be x minus 3 times x plus 3. And then on the bottom, we're just thinking what two numbers multiply to negative 3 and add to negative 2, which is just negative 3 and 1. So it's going to be x minus 3 times x plus 1. And here you can see that there is an x minus 3 on both the top and the bottom. So we can cancel those out, and that is our whole at x equals 3. And then we still have this x plus 3 on the top, and that can't get canceled out, so it's going to be our 0 at x equals negative 3. And then on the bottom, we still have this x plus 1, so we're going to put that as our vertical asymptote at x equals negative 1. And then our y-intercept, we're just going to see what the function equals when we plug in 0 for x. So in this case, it'll just be negative 9 over negative 3, and that's just 3. So the y-intercept will be at 0, 3. And then for your domain, you're just going to make sure you're not including any of the x values that we mentioned for the vertical asymptote or the holes. So we can do negative infinity to negative 1, then negative 1 to 3, and then 3 to infinity. And that's it. Alright, now this one's just a little bit different because we're going to be finding all of these factors just based off the graph rather than the rational function. So here right off the bat, you can see there's a hole at x equals 1, 2, 3, 4, 5, 6, 7. So you can go ahead and put that. And then there's a 0. It's a little bit hard to see, but right here at x equals 2 and x equals negative 2. So you can go ahead and put those. And then vertical asymptote, you can see there's one right here at what looks like x equals negative 4. And there's no horizontal asymptote, so you can put none. And for the y-estimate, they're saying estimate because it's kind of hard to see right here, but I'd say it's about negative 0.3, maybe 0.5. And domain, you just make sure not to include your holes or your vertical asymptotes. So you're going to put negative infinity to negative 4, negative 4 to 7, and finally 7 to infinity. And that's it. Okay, for this next one, we've already done problems similar to it. We're going to do it just for practice. It's already factored out for us, which is really nice. For the sake of our horizontal asymptote, you might want to factor all the way out, but you're just really looking for what the highest power will be, and because it's just two x's, it's just going to be x squared, which means the power on the top and the bottom will be equal. So you can look at the coefficients, which is 4 over 1. So there is a horizontal asymptote at y equals 4. And then for our holes, we can see the bottom is a difference of squares, so it'll factor out to x minus 2 times x plus 2. And right here we can see there's an x minus 2 on the top and the bottom, so we can cancel those out, and there's a hole at x equals 2. And then for the zeros, we can see we still have this x plus 5 on the top, so there's going to be a 0 at x equals negative 5. And I'm going to delete all of this so it's a bit easier to see. And then vertical asymptote, we still have this x plus 2 on the bottom, so there's a vertical asymptote at x equals negative 2. And then for your y-intercept, you're just going to plug in 0 to the original function. So it's going to be 4 times 5 times negative 2 all over negative 4, which is just negative 40 over negative 4, which is 10. So the y-intercept is at 0, 10. And for your domain, you just don't want to include your holes or your vertical asymptote. So it's going to be negative infinity to negative 2, negative 2 to 2, and 2 to infinity. Okay, now for 1.9, we're really going to be focusing in on limits, specifically limit notation. So here we're asked about vertical asymptotes start off, and here we can see there's one at x equals -5 and x equals 2. So we can include those. And then we're asked, as x approaches -5 from the left, the f of x approaches -infinity. So what it means by approaching -5 from the left, it's as we're moving this way. So here, f of x approaches -infinity. And this is different from when x approaches -5 from the right, because it's as we're moving this way towards -5. It's actually going towards positive infinity rather than negative infinity. So you have to be careful to check from both sides because they may not always be the same. Now, limits can be shown in a matter of ways, and here it's shown numerically. For the sake of time, I went ahead and put in all of the y values for these x's, but you have two options. You can either use the calculator trick that we learned in the last lesson, where you make a table of values and plug in each x, or you can just go ahead and put it in manually, plugging in like 1.9, 1.99 into this function and getting your y values. But once you do all that, whichever one you choose, it will spit out these values. And you can see that as x is getting closer and closer to 2 from the left side, it's getting closer and closer to -infinity. So here we can say approaches -infinity. And for as x approaches 2 from the right, so getting really, really close to 2 from the right side, you can see it's getting closer and closer to positive infinity. So now we can put it in proper limit notation. So the limit of g of x as x approaches 2 from the left is -infinity. And the limit of g of x, posture check, as x approaches 2 from the right is positive infinity. Okay, now multiplicity is where you need to start being really careful about your vertical asymptotes and holes, because this is a really easy way to lose points on your AP exam or just your test in class. So we're going to go ahead and start factoring at the top. What two numbers multiply to -12 and add to 4, and that is 6 and -2. So we can factor this out to x plus 6 times x minus 2. And on the bottom, we can just kind of expand it out to see what we're looking at. So x times 2 times x minus 2 times x minus 2. And here, it looks like you can cancel out x minus 2 and x minus 2, which you can, but that doesn't mean there's a hole, because we have this little guy right here, which means that there's already a vertical asymptote at x equals 2, so you're not going to include that hole. So there's no holes. Okay? For horizontal asymptote, you can look at the powers of the top and bottom. They're equal, so you can look at coefficients. So there's just a horizontal asymptote at y equals 1. And then zeros, we have this x plus 6 on the top, so there's going to be one at x equals -6. Domain, not going to include your vertical asymptote or holes, don't have holes, so it's going to be -infinity to 2 and 2 to infinity. And for limit notation, it's honestly, if you really want to draw your graph, it's pretty easy because you have that horizontal asymptote and vertical asymptote. So what it's going to look like: horizontal asymptote at y equals 1, vertical asymptote at x equals 2. So the graph is going to look like this. And you can write the limits of each of x as x approaches 2 from the left, so this one right here, is -infinity. And the limit of h of x as x approaches 2 from the right, which is that one right there, is positive infinity. And that's it. Okay, now this part's fairly easy. You're just looking at the table and finding these values. So d of 0 is undefined. You can see it right here. Limit of d of t as t approaches 0 from the left. So it's as it's approaching right here, it's getting closer and closer to infinity, as you can see from these values on the right. And e is just asking the same thing. As t approaches 0 from the left, d of t approaches infinity. and then find the y-intercept. Y-intercept doesn't exist here because that would be where t equals 0, and that's undefined, so it does not exist. Whichever I'm going to say. And then find the limit of d of t as t approaches 0 from the right, so it is going this way. It's getting closer and closer to infinity. On this side, by the way, you're not looking at the left for actual limit. As t approaches 0 from the right, d of t approaches infinity. We are actually going to be trying out a multiple choice question so that we can practice ruling out answer choices. So here we have the graph, and we're just looking at which of these correctly describes the function. So limit of f of x as x approaches -4 from the left equals -infinity. So we can check if that's true. -4 is right here, so there's that vertical asymptote. As it approaches it from the left, it's actually approaching positive infinity, so we know this one's already out of the league. So here we can see it's actually saying it correctly, so we can look at the second part. Limit of f of x as x approaches -4 from the right is -infinity. That is correct, so we can put a star right by that one because it can't be this one. Here, same thing, it can't be the answer choice for the same reason as A. Here we see that it actually is saying positive infinity, so we can look at the second part. As x approaches -4 from the right, f of x approaches infinity. That's incorrect because we said it's going to -infinity. Limit of f of x as x approaches -4 is equal to f of 0. Well, first off, the limit of f of x as x approaches -4 doesn't exist because we know that from the right and from the left they are not equal. So we know that E also is wrong. So we know the answer choice is B. And that is the end of our lessons. I know that was a rather long video, so I do apologize. But we did do 1.8 and 1.9, and the next will be 1.10, if I can do my math. But yeah, I'll see you guys in the next one, and I will be including all of the problems in the description, so you can either follow along with me, do extra ones I didn't go over for extra practice. And yeah, I'll see you in the next one.